CoCo Crew Podcast is hosted by CyberEars. If you are serious about your podcast hosting needs, you should check out CyberEars. Whether you are a podcaster, a radio host, a musician, a narrator, an audiobook author, or simply a school, church, corporation, or anyone else with an audio recording that needs to be hosted or distributed, you should check out cyberears.com. Unlimited bandwidth, fast, reliable, and rugged servers with no hidden fees. CyberEars, your audio, your terms.
Listen, it's getting closer.
Hey, you got your CoCo 3 yet? Hey, you got your CoCo 3 yet?
You're listening to the CoCo Crew Podcast, a delicious adventure into the world of retro computing news and information featuring the Tandy Color Computer. All right, welcome to episode 2 of the CoCo Crew Podcast. This is John Linville.
And Neil Blanchard.
And we are the CoCo Crew. It is late July, and we are in the dog days of summer. It's warm outside, and both Neil and I have had opportunities to sample some warmer weather lately. But we're trying to stay in the swing of things and get on with another episode and talk about some CoCo. Let's see. So this episode, we're going to have another technical segment from me, and we're going to have another game review from Neil. We're going to cover some news in the community and maybe cover a little listener feedback, and hopefully it'll be a good show. All right, so just a few announcements. Not really any news here, but we do have a Facebook page for the podcast. It's the CoCo Crew Podcast group on Facebook. Just join up there and watch for our little announcements. We usually try to post a few things here and there during the month.
And we're also available on iTunes and Stitcher.
We are available through email. We prefer that you send email through the cococrew.org domain, so you can reach both Neil and I at either show at cococrew.org, podcast at cococrew.org, or feedback at cococrew.org. And you can reach us individually as John at cococrew.org for me, and Neil at cococrew.org for, well, Neil. Let's move on to the news.
I know I keep saying this every show, but I just can't get over the amount of news, like the projects going on in the community, especially in the summertime. Like, it's amazing.
Yes, it is amazing how much new stuff happens on our 30-plus-year-old computer.
It's great to see.
So, I've got a few little news items here. One thing I wanted to mention while checking out the VZ200 Yahoo group, I guess, the mailing list there. VZ200 is a computer that is sort of related to the CoCo. It uses the same video chip, the 6847, with a Z80 processor, and apparently was reasonably common in Australia. And it was available in other parts of the world too, both as the VZ200 and as the VTech Laser 200, I believe. Anyway, someone made a little announcement there that they had a podcast that sometimes covers some VZ200 talk, and that is the Old Fart Geeks podcast. So if you're interested in the VZ200, and looking for another podcast, you may want to devote some time to checking that one out. Another news item: we have now the Super Logo cartridge has been imaged and made available for download through the colorcomputerarchive.com, thanks to the efforts of Guillaume Major. I'm not sure the proper pronunciation. I assume that's probably a French pronunciation. Anyway. It reads like Major. Hopefully that's an adequate pronunciation, Guillaume. If I've really messed it up, then please let us know. Anyway, Super Logo, of course, is a enhanced version of the Tandy logo for the color computer. Not exactly sure off the top of my head what all of the enhancements were, but it is supposed to be the reviews. I remember reading the reviews and indicating that it was a much better version all around than the plain old color logo cartridge. I've seen other people say it's not quite as good as the DL logo package that was available for OS 9. Anyway, if you're a logo fan, you may want to check that out. Moving on, there's a thread at Atari Age. They now have a Tandy Computers subgroup or sub-forum that is getting some color computer traffic. That thread includes, there's a thread there that where someone's documenting some good results they've had getting RGB output from a CoCo 2. So this is a little bit different than some of the other projects we've talked about, which produce composite video. This one, I think he's hooking it up to just a prepackaged box that's designed to adapt signals to HDMI. He's got a picture. He's tapped the motherboard and 3 or 4 wires is running out. Oh no, it's not a prepackaged box. It's
start to HDMI converter.
Yeah. So he's got a circuit with some transistors. It looks like quite the little project. But if you're technically inclined or just interested in what's going on, you may want to check out that thread on Atari Age and see what you can learn. I will note that if you switch to an RGB video output on a CoCo 1 or 2, in most cases you will be giving up the artifact colors that are so prevalent in CoCo games, at least in North America. So you may get nice, crisp, easy to read characters on the screen, but you may end up with games that are only in black and white. So caveat emptor. Okay, so the next item on the list is a link from Facebook. It's from Paul Thayer, and he has got a release of his sprite editor. This is Sprite Editor 7 is almost complete. I just need to figure out the math for the scroll bar. Let's see, you can draw sprites 64 by 64, 32 by 32.
Which that's ideal for CoCo game programming.
Yeah, it's definitely very handy. I think, if I recall, this is written in BASIC, and this is for the Color Computer 3. And so I think Paul is using it for his own projects. Didn't he have some kind of run and gun game where you were shooting Canadians or something?
Yeah, he had a platform game he was working on.
Yeah.
Yeah.
I don't know why anyone would just want to shoot Canadians. They're such nice people.
Yeah, that's not a nice...
Anyway, hopefully Paul is Canadian and he's not just picking on our neighbors to the north. But anyway, it's got there's a link available through it's a posting available through the TRS-80 Color Computer group on Facebook. You may want to check it out. I think he's trying to develop a tool set to help people write games. So
that's a good thing. We need that.
It definitely is a good thing, and it's always good to get more involvement from people who either basically just don't have time to do their own tools or aren't very comfortable typing hexadecimal numbers into source code to create art. It's a talent not everyone has.
Yeah.
Our next item is an update from Nick Marentis to his game Neutroid. And so Nick has had a site out for a while where he has documentation or sometimes it's stories about his various CoCo and other gaming projects over the years. And one of those games is called Neutroid. It's a game involving some kind of attempt to shut down a nuclear reactor, I guess. I'm not entirely familiar with it. I know that it does use some of the semi-graphics modes for a nice colorful display. Anyway, he's recently gone back and updated that with some various improvements as documented on his page, and he's released his update as Neutroid version 2.015, which of course from a distance looks like Neutroid 2015.
Very creative. The other thing to mention on this is that this version is CoCo 3 compatible. Well, it's actually for the CoCo 3, where apparently it didn't work on the CoCo 3.
Right, so because of the semi-graphics modes Normally that will not work on the CoCo 3. There is some tricky little pokes that you can do, that things that probably aren't totally supposed to work, but they happen to work, and it's been
it's like a kind of a workaround.
Observed. So you write values of the registers that don't quite match with the documentation for what the registers are supposed to do, but it does enable at least the graphical bits of the semigraphic modes to display on a CoCo 3. So I guess that's the main point of his update, was to bring Neutroid to the Color Computer 3. I haven't had a chance to try it out, but it does look like a cool game, and I'm looking forward to giving it some playtime. All right, so the next item on my list is that we mentioned the CMOC or CMOC compiler from Pierre Sarrazin in an earlier episode, and he announced he's got another update. Version 0.1.8 is what I have documented here. Let's see, he added a check stack option so the compiler does some runtime checking of the stack. He's got an sprintf function, some C preprocessor support, some optimizations, bug fixes. Anyway, it's cool stuff. The main point here is he's got a tool that he is actively working on, trying to improve. So looking forward to good things continuing to come out from Pierre, and hopefully other people find his tools useful and can produce some cool stuff with it. So thanks, Pierre. Okay, the next item I have is from Brett Gordon, who has announced that he has Fusix booting on a real CoCo 3. So again, we mentioned Fusix in an earlier episode. This is a Unix-like, kernel plus runtime environment now, I guess, that originated the project from Alan Cox that is getting this Unix-like system booting on a number of 8-bit machines, and Brett is working with him and has it running on a CoCo 3. So it's great to see some traction there, and it's great to see the CoCo 3 included in the mix. And it's another one of those things I'm looking forward to trying out, but I just haven't got there yet. The next item called the RGB monitor test from Richard Gerdikin. Richard, if I'm messing up your name, again, send us some feedback. Tell me how to pronounce it. Richard has produced a bit of code that I guess is intended to help test out RGB monitors. You plug them into your CoCo 3 and you need something to display, and you test out all the various colors and that sort of thing. He's posted it to the list as a zip file. It says the 225 line version fits perfectly in my CM8 display. In addition to using this with real CRTs, it's also nice for developing and testing the VGA converters like Roy's or Lewis's.
Hey, that's a handy utility, especially now with all these different RGB to VGA boxes that are coming out.
Yeah, definitely a cool addition to
good timing.
The community's tool set. So thank you for your contribution, Richard. And, like I say, we look forward to more good things in the future. Okay, this is one that it's just come out this week, I guess, from Darren Atkinson, and he's calling it the MC11. And so basically, he's got a machine that he's developed something that's similar to an MC10. The MC10, of course, uses the 6847 video chip along with a 6803 processor. Darren has now got a new board that he's developed that is based around the 68HC11, which is essentially a follow-on device, a later follow-on or more modern chip that he's developing the board to be, like I say, reasonably compatible, at least with the MC10, and it's going to boot up and run basic programs. And I don't know. Sounds like a cool project. All I've seen so far is that he got PCBs back. They look like the Osh Park PCBs of the characteristic purple color. So knowing Darren, he'll find a way to make those available to the community in the future. I hope so. Might be a cool project for some hacking.
And from what I read, he's going to use SD cards in favor of tape access.
That's right. He did say he was eschewing the tape access in favor of SD cards, and I'd say that's probably a great thing to do for a modern machine. Okay, so our final news item, which kind of saved the best for last here, is so a couple of years ago, Sockmaster, or John Kowalski, produced a fantastic Donkey Kong port for the CoCo 3, which he did a combination of essentially doing a binary translation from the Z80 opcodes to 6809 opcodes for the bulk of the program. And then in the parts of the program that access the Donkey Kong hardware, he, rather than changing those bits of code, he apparently implemented what amounts to a Donkey Kong hardware emulator that runs on the CoCo 3. So it's basically the best, or certainly the most accurate version of Donkey Kong I've seen run on any 8-bit computer. And that's been available in the community for several years now. It was released, 2007?
2007, yeah. And it plays just like the arcade version. It's pretty well, it's identical, really. It
is, like I say, it's probably the most accurate version I've seen. Yeah. Anyway, I guess there are a few things that, as the programmer, Sock was aware of that weren't quite right or whatever. So eventually he found a way to return to his creation and fix a few things here and there, make some improvements. And I guess along the way he had figured out a bit more about how the Donkey Kong program actually works and does things. And so he made some enhancements and added some new levels and changed some behaviors of existing levels. And so he's this week released an enhanced version that he calls a DK Remix. We'll have a link for that in the show notes. Sounds pretty cool. In fact, at one point, while he was working on it, I saw him remark that he's hoping to get some of these level enhancements made available actually on Donkey Kong, the arcade hardware as well. So this may be your first chance to play this enhanced version of Donkey Kong. May actually be on the CoCo 3 before it goes back to the actual arcade hardware. So
that's another excuse. If you don't have a CoCo 3, you can run out and get one.
Yeah, if you don't already have one, it might be too late, according to discussions about eBay that have been
gone up
recently. We are seeing some prices for CoCo 3s approaching $300, or even breaking maybe $300. That's US dollars.
Oh yeah, that's that hurts us Canadians.
I don't know if that's actually going to be the new normal, as some people have said. But the prices right now are at least above 200 for CoCo 3s. And, is this good or bad long term? It may be hard to tell. Certainly some people aren't too happy about it. I suspect people that are sitting on a truckload of CoCo 3s might be very happy about it. So,
yeah, they might be time to cash in.
Anyway, that wasn't actually an official news item on the eBay discussion, but hey, it slipped in anyway. So if you want professional podcasting, I guess you'll still have to search elsewhere. But for now, we're the best you've got. Okay, so I think that probably concludes our news section. So I think that's probably enough for now. There's probably a few things that we've left out here and there. If they turn out to be important, we'll try to cover them next month.
Okay, but why Tandy Computers? In a word, quality. We do it all, from custom-designed semiconductors to the finished product. Tandy business computers are manufactured in our own USA plants. We test and retest and test again to ensure one of the highest standards of quality in the industry. And Radio Shack provides total service and support. I'm convinced.
Tandy Computers at Radio Shack Computer Centers. In business, for business.
Okay, let's talk about a little listener feedback. One thing is I finally screwed up somebody's name enough that they sent me some correction email. That's Jim Gary, who is the prolific games programmer in BASIC that we talked about on a previous episode, where Jim produces lots of BASIC games, mostly for the MC10, I think, is his primary target. But since the color BASIC on the MC10 and the color BASIC on the CoCo are very similar, most of his games end up making their way to the CoCo as well.
He does a lot of conversions, converts them for the CoCo.
Yeah, definitely. So Jim was nice enough to send us an email pointing out his last name is pronounced Gary, and not Jerry or Jiri or whatever else we were thinking. Yeah, so
we both got that wrong.
Yeah. So I'm going to say it correctly one more time, Jim Gary. And he sent us a couple of links to his games. We'll include those in the show notes for anyone who has trouble finding them. But so anyway, Jim, you're a great guy. Thanks a lot for setting us straight on the pronunciation. And I hope to continue to see lots of basic games from you in the future. Let's see. Someone else who wrote in, Steve Bamford. Hope I'm saying that correctly. Steve's a listener from the UK, and so he's actually, I think, a Dragon user. Let's see. He writes in, says he enjoyed listening, says we're both interesting and informative. So, maybe he doesn't get out enough, but let's see. He says, as a newcomer to programming, and then in parentheses, I made a little 6809 Flappy Bird clone, and then I would welcome further programming-oriented segments in future episodes or interviews with CoCo developers discussing their games/apps and perhaps sharing a trick or two. Keep up the excellent work, and long may you continue. Well, so thank you, Steve. That was great. I love his parenthetical reference to his little 6809 Flappy Bird clone. If you haven't had a chance to find that, that is a cool-looking little game. It looks about as good as any other Flappy Bird clone that's out there. Which I think is pretty impressive.
If anybody's interested, it does run at a very good clip. Like the speed is very nice on it, smooth.
And like I say, the Flappy Bird clones seem to have been pretty common in the 8-bit world in the past year or two. So here's a link to a YouTube video. I'll make sure to put that in the show notes. How's that? Anyway, it's good to get some feedback from our Dragon friends. Nice to know they're out there appreciating the podcast as well. So, Steve, thanks for writing. Okay, one other feedback we got kind of from a couple of folks asking for timestamps in the show notes indicating when the segments start and stop. I think we'll try to do that starting this episode. We'll see how it works out. If it may or may not be a pain in the butt, we'll see. Anyway, that's I think that will do us for listener feedback this round.
This episode of the CoCo Crew Podcast is brought to you by the numbers 6, 8, 0, and 9, and the letter E.
Okay, well, welcome back to the second part of our series of technical discussions on the CoCo architecture. This time we're going to talk about the 6847 Video Display Generator, or VDG. This is the graphics chip on the color computer. Unfortunately, it may be the weakest part of the CoCo. It's kind of ironic that a machine called the color computer is powered by a device which has sort of a questionable set of colors available to work with, and certainly not the strongest combination of graphical assets. But anyway, it is what it is. So we're going to talk about it, and we're going to start with talking a little bit about some the people involved, some history. The 6847 came out of the Motorola 6800 microprocessor design group in Austin, Texas. We mentioned Terry Ritter, who was a co-architect of the 6809 in the previous segment. Terry Ritter was also listed as a co-architect for the 6847. Apparently he had a strong background in NTSC signaling. NTSC, of course, is the color television standard for analog television in North America. Don't have a lot of other information who was involved. Did have an email exchange with John DeMoss, who's a member of the CoCo community on the CoCo mailing list. John apparently was somehow found himself as a project manager for the 6847. But he really was a software guy, and in fact he wrote to the the monitor program used on the Microchroma 68 development board, which we'll talk about a little bit in a minute. That's about all that I really have as far as people involved with the design. There were a couple of guys, or three, Tim Arens, Jack Brown, and Hunter Scales are mentioned in some, they show up as authors for some articles, one in particular called A Low-Cost Digital System Interface to a Color Television Set, which apparently is in the proceedings from the fourth West Coast Computer Fair from May 1979, author Tim Arens. Unfortunately, I couldn't get that article, so if you have it, please forward me a copy. That'd be great. As a side note, those same proceedings apparently have an article about Green Thumb, which was a project involving Tandy and Motorola and the U.S. Department of Agriculture that ultimately is supposed to have led up to the development of the color computer. There's more information about that in Boise and Bill's book on the history of the CoCo. So you may want to check that out. Anyway, Tim, Jack, and Hunter also show up as the authors of an article in the March 1981 edition of Byte magazine called What's Inside Radio Shack's Color Computer. Not exactly specific to the 6847, but certainly pertinent to the audience here. You may want to check that out if you can find a copy online. Anyway, Tim, Jack, and Hunter were application engineers working at Motorola in this group. Application engineer, if you're not familiar, is essentially it's a technical salesperson who guy who answers deep technical questions in support of sales to customers. And so apparently they did some amount of that writing in hopes of selling the 6847 and 6809 other chips out of that group.
I'm in love with the CoCo. I'm in love. I'm in love with the CoCo.
The 6847 had a number of interesting usages. One in particular, of course, was the Microchroma 68, which is essentially a development board used or as a sales aid even from Motorola. I actually managed to get an unbuilt Microchroma 68 kit from John DeMoss some time back. And then a couple of years ago, I actually built it as a retro challenge project and got code running on it. It's a nice little board with a 6808 microprocessor and, of course, the 6847. It runs a monitor program called TV Bug, which basically just lets you load software on the device and run it and experiment with it. In some ways, I think this is very similar actually to the capabilities and the kind of experience you get with an Apple One. It's sort of a TV typewriter style of application. So no doubt they were trying to showcase the ease of use of the 6847 chip in that style of application. Another device that sounds pretty similar to me was something for the TRS-80 Model 1. Is a device called the Electric Crayon, which actually interfaced to the Model 1 through the printer port. Sounds like the device itself was a 6802 microprocessor and, of course, a 6847 video chip. So the 6802 would be very similar, of course, to the 6808. I can't but wonder if or how similar maybe the Electric Crayon schematics are to the Microchroma 68. Anyway, the Electric Crayon was programmed actually by sending commands out the printer port as basically a letter and arguments. So like you'd send I don't have it in front of me, but say like an M for setting the mode or a C for setting the value of a CSS color set select pin or that sort of thing. So there's a way to get some color graphics out of your Tandy Model 1. Side note, as I understand that Steve Bjork, the famous CoCo game programmer, actually got his start with the 6847 programming stuff for the Electric Crayon. If you happen to have one for sale, please let me know. I would like to have one of these devices. Anyway, So another device that's out there that uses a 6800 processor, and the 6847 was the APF, the Imagination Machine, or actually the M or MP 1000. Sometimes you see it as M and some as MP 1000, which is basically a little home video game box similar to an Atari 2600 or an Intellivision or whatever, and you would plug in cartridges and play video games on it. Then when mated with this larger Imagination Machine, basically a dock for the video game machine, provided a keyboard and a cassette interface and maybe some RO expansion. Anyway, it's kind of a common concept at the time of how do you have a video game and a computer? And anyway, that device is out there. It used a 6847, not super popular device, but it did exist, and actually from a hardware perspective, had some interesting usage of the 6847. Another device that's out there is the Acorn Atom, which was an early machine from Acorn, a predecessor to the BBC Micro. That machine used a 6502 CPU and a 6847 VDG. Pretty basic computer, ran Cambridge Basic, I guess, or probably roughly similar to running a CoCo or whatever else, just a different machine from a different company. Similarly, the VTech Laser, or the probably better known as the VZ200 from Dick Smith, was a machine available in Australia, maybe other parts of the Pacific. That one had a Z80 processor and the 6847 for video, and again, a machine that's pretty similar to a CoCo in a number of ways. Certainly the graphics will look fairly familiar to you. There's a machine from NEC called the PC 6001, or the 6001A in the United States, and that version was sometimes called the TREK or Trek, or sometimes you hear it called the NEC Trek. That had a Z80 processor and the 6847 as well, although the wiring there was it was wired in a sort of unique way to get some extra features out of the hardware. Another machine that I'm not very familiar with was called the CCE MC1000. Apparently some of our CoCo friends from Brazil are familiar with this one. There's a Facebook group out there available for it. Its specs are similar to the NEC Trek. It's a Z80 with a 6847. I don't know a lot about it, but it is out there. It did use the same chips. So, of course, the Tandy color computer and the Dragon 32, Dragon 64, Tano Dragon all use the 6847 for their video. We got some enhancements to our capabilities with the combination of the 6883 and the 6847. Was able to add a couple of extended video modes for us. Probably talk more about that when we talk about the 6883. And of course the Tandy MC10 or microcolor computer, that again had a 6800. Well, actually, I guess that's a 6801 or 6803. Anyway, it's a 6800 based CPU and a 6847 graphics chip. It does not have the 6883, so it's not quite at the same graphics capabilities as the CoCo. It's probably more on par with what the VZ200 or the Acorn Atom had. Anyway, another machine that used the 6847, and so when you see graphics output from that machine, it'll look very familiar to you.
Some people have big plans after school. You know what Elliot's going to do? Jeff, too. Elliot's at work on a book report using Scripted on Radio Shack's Color Computer 3. It hooks up to his TV. And Jeff's at his Radio Shack Color Computer 3 playing the newest football game. But wait, what's Elliot doing playing new Super Pitfall? And Jeff's having a blast with a new math tutor. You never know what you might try with more than 100 programs for fun and learning. Radio Shack's Color Computer 3 comes with everything you see here. Other items each sold separately. Only at Radio Shack.
Okay, I'm going to now try to run through some of the features of the 6847 VDG. The VDG has two major modes, one that's a text or semi-graphics mode and one that's a full graphics mode. Selection of the modes is done via signals on the external pins to the chip. So there's no register to set in the 6847 for a video mode. You actually control it through what are typically GPIO pins. So there's a pin that selects between alphanumeric and graphics mode, another pin that selects between alphanumeric and semi-graphics mode. Those two pins kind of combine to select sort of the major mode that you're using. Alphanumeric, of course, is a typical text screen. The graphics mode is a typical bitmapped screen with pixels. The semi-graphics is sort of a large, chunky pixel graphics mode with the graphics set on character boundaries. There's a pin called invert, which is used in the alphanumeric mode for changing between foreground and background colors for a given character. There's another pin for internal or external character generation. You can use either the internal 6847 character generator ROM, or you can provide one yourself. And there's support on some other pins from the chip for making that work. There's 3 pins, GMO, GM1, GM2, that are used for selecting specific graphics mode. That should be, obviously, is for selecting with the specific resolution and color settings that you want to use. And then there's one more pin called CSS, which is for selecting which set of colors you want to use in a given mode. Not all of these lines are actually useful at any given time. It sort of depends on the exact combination in use. Sometimes certain settings will render settings on other lines irrelevant. The mode of the display can be changed basically on a per byte basis. This works best when you're switching between text and semi-graphics modes, or between sometimes similar graphics modes for, say, setting a CSS differently per byte. Those values, again, because the mode selection is driven via external pins, those pins can be driven either through the actual character data itself or through external settings like GPIO pins on, say, a PIA or some other chip that's part of the system. In the text or semi-graphics modes, there are a collection of 32 by 16 cells in the screen. Each cell represents basically 8 by 12 black and white pixels, and the default internal character generator will take up 5 by 7 pixels for each character glyph, such as the letter A. In alphanumeric modes, you have combinations of colors. You can either have a light and dark green or a light and dark orange. That's chosen based on the value of the CSS pin. The bitmaps for those characters comes either from the internal character generator or the external one, depending on the settings of the int_ext pin. In semi-graphics mode, SG4 mode, you have 4 blocks per character. All 4 blocks are either turned on or off, sharing the same color, one of 8 colors, or if they're off, they can be black. There's also in semi-graphics 6, SG6 mode, where each character is divided into 6 blocks in a 2x3 configuration. As far as the chip is concerned, those blocks can be one of 4 colors or black if they're turned off. Which set of 4 colors is determined by the setting of the CSS pin as well. In the graphics mode, you can have either 2-color or 4-color graphics modes. In the 2-color modes, you're selecting between either black and white or black and green. In the 4-color graphics modes, you have one of 2 palettes, either a green, yellow, blue, red palette, or a buff, which is essentially white, so buff, cyan, magenta, orange palette. In the graphics modes, there are resolutions available of 64 by 64 in 4 colors, 128 by 64 in either 2 or 4 colors, 128 by 96 in either 2 or 4 colors, 128 by 192 in either 2 or 4 colors, and 256 by 192 in 2 colors. Each of those modes will use a different amount of memory that is computable based on its size and color depth. The chip, as mentioned, can support an external character generator ROM, or it has its own internal character generator ROM. The external one can be useful. In the CoCo world, it was often used to provide real lowercase letters instead of just the inverted uppercase letters. It can also be more interesting than that. You can program it with graphics elements for, say, the background of a game, or even the characters in a game, depending on exactly what you want to do. 6847 is available both in interlaced and non-interlaced versions. Interlacing is a video generation topic. By default, NTSC video is interlaced, but the 6847 version using the CoCo at least is not interlaced. This can cause problems with some NTSC displays. Most TVs work fine, but some of the newer converters don't always accept CoCo video very well. It's a topic for another show. But anyway, the version used in the CoCo is the non-interlaced version. The 6847 does not actually produce a composite video signal with full color information. It produces a black and white video signal or a Luma signal, and then two separate chroma signals that have to then be combined external to the chip. The Motorola MC1372 chip was specifically built for that. There are other chroma encoders that can be used. There's also these values together can be treated as a sort of a converted form of RGB, and so that you can actually break them back out into, or use them as discrete signals and convert them back into an RGB or other signal that is used commonly in the Acorn Atom world, and in a few other places where people have tried to use the 6847 in more modern times. So let's see, some downsides to the 6847, as I pointed out, or maybe it was not entirely clear, but there are no palette registers. The palettes are pre-selected specific sets of colors depending on the exact mode, but you have to deal with what colors you're given. You can choose a little bit, but you can't choose specific colors. So that's sort of a downside. There are no sprites at all, so any kind of animation you want to do has to be done through brute force of the CPU, moving data around. It's just a fact of life with the 6847. If you want to use any sort of character graphics, you either have to use them with the blocky semi-graphics characters or with your own external character generator ROM. In either case, you're talking about fairly low resolution and essentially fixed values. It makes it difficult to use a 6847 for any kind of tile-based graphics application. It's not impossible, but there are severe limitations. The best thing I can say in favor of the 6847 is that it is kind of dumb and hackable, which means that while it doesn't necessarily provide you a lot of help, if you are clever enough to write software that switches the settings on the chip pretty quickly, it doesn't get in the way with it, and it'll do its best to present what it thinks is the correct data at the correct time. I've used this a little bit myself in a game called Sluzzle, which would change the CSS while the screen was being displayed to get effectively 8 colors on the screen at once, or a bit more, because Sluzzle did a few other tricks. Simon Jonason has been abusing the 6847 in combination with the 6883 to do a number of interesting effects, some of which are from abusing the 6847 itself, and some are from abusing the 6883, but in both cases they're hackable dumb chips that just sort of do what they're told, and that can be useful. Anyway, so there's a hopefully quick enough summary of what's available with the 6847 VDG.
The following program could have been produced by a pair of donkeys wearing roller skates.
So, a few extra notes about the 6847. One thing to note is that it was possible to order the 6847 with customized built-in characters. So if you needed to replace the depiction of a given character for whatever reason, you could do so. It'd probably be pretty hard to find a new one like that today. Anyway, it was a possibility, so it's possible that you could find 6847 equipped devices that had different glyphs for certain character values. It was common when using the 6847 to control some of the modes using data from the screen itself. This is used on the CoCo, for example, to turn on semi-graphics versus alphanumeric modes, and also used to control the inverse line to display lowercase characters as inverted uppercase characters. This is actually, I can't find it right now, but I've seen this actually recommended in some of the associated 6847 design literature. So it was actually contemplated by the design team and as a useful feature. A couple of the devices mentioned earlier, the NEC Trek and the APF Imagination Machine, or M1000 arcade machine, used some of that kind of thinking to some clever wiring to extend the features available to the 6847. They actually control the CSS, the color select pin from some of the graphics data in some cases, or actually the M1000 in particular, I think rewire some of the addressing to actually get some programmable character generation out of the chip. There's a lot of neat things you can do if you're a clever hardware guy. Along the same lines, the SemiGraphics 4 mode can be probably the SemiGraphics 6 mode could have been exploited similarly, but the SemiGraphics 4 mode was exploited in systems in the CoCo, for example, or other systems that use the 6883. The 6883 datasheet that described how to connect them together so that you could get some extended semi-graphics modes, so that you could get 8, 12, or even 24 blocks within a character. This is used somewhat in the CoCo world, not as well as it should have been, but for example, my game Farfall uses SG12. One important thing noting in the CoCo world is the highest resolution mode, the 256 by 192 by 2 color, the black and white version. That highest resolution, NTSC color actually only allows for about 160 color changes in a line, and so anything higher than that, and we're actually aligned with the CoCo so that you're not, that 256 only takes up about 128 clock cycle or color clock cycles on an NTSC screen. So any larger of resolution or any more variation, it creates a situation where the spatial resolution actually fools the color decoding circuits in NTSC video, so that you, by putting patterns on the screen that are supposed to be, or in black and white will be, higher resolution graphics, in color mode they'll be viewed as color encoding, and you'll produce more colors. And so this artifact color mode is quite commonly used in CoCo games, and so you get 4 colors, black, white, and then you get a usually called red, it kind of looks orange to me, color, and then a blue color. It's almost closer to a cyan, but it's a lighter blue color, and so that's an extra 4 color mode. It's essentially another 128 by 192 4 color mode, because you need 2 black and white pixels for each one of those color translations. But anyway, we could probably do a whole segment just on artifact colors and how they really work. I actually did a YouTube video talking about the CoCo 3s. Has a way of reducing artifact colors up to 256, or not quite that, but 8 bits worth of artifact colors on a CoCo 3. There's a YouTube video out there. Maybe we'll put a link to that in the show notes. It explains the basic concept. The CoCo 2 can't do that many. It can only do the 4 colors, but it essentially does it the same way. And then notably, this is also the same way those colors are generated in high-res mode on the Apple II, and on the, I forget what the numbering of the modes on the Atari, but the Atari 8-bits had a similar mode. That the Atari 8-bit people will know that they have a mode that's similar to the high-res mode on the Apple II, and that's also similar to our high-res mode. Anyway, moving on.
Radio Shack understands that a computer purchase is a serious personal and business decision. But what's really important is the company behind the computer. At Radio Shack, when you buy a computer, you buy a company. A company committed to technology, service, and support. We'll be here when you need us. With a telephone hotline, training, education, and excellent service. Tandy Computers, in business, for business. Tandy, clearly superior.
All right, since we're talking about the 6847 and the CoCo, we should also mention that some later versions of the CoCo 2 came with a chip called the 6847 T1, which was often also marked, or instead marked as the XC80652, which apparently is some sort of customer order marking convention that Motorola used back in the day. Anyway, the 6847 T1 is pretty similar capabilities to the standard 6847. It does have, it has the capability of producing lowercase characters, but instead of just simply, having burned a new character generator ROM or something, they kind of created an enhancement where basically they made the graphics mode pins significant even when you're not in graphics mode, and then they use that to enable some new features. And so with the proper settings of the graphics mode pins, you could get true lowercase characters from the 6847 T1s, or these are commonly called the CoCo 2Bs, which may or may not be a totally accurate nomenclature for which machines had these or not. But anyway, you could have true lowercase characters displayed if they were properly enabled. By default, you still got the inverse uppercase characters for your lowercase displays. So go figure. That's the way they decided to do it for compatibility, no doubt. Another feature that was available was that instead of, so in the normal 6847, the background color was tied to the basic mode that you were in, and so alphanumeric and semi-graphics modes would have a black background, and the full graphics modes had either a green background or a buff or white background, depending on the setting of the CSS pin. That's, debatable as to whether or not that should have been the case, but apparently somebody thought it would be nice to have the black background available in the graphics modes, and so that is an option on the 6847 T1 as well. Looking at the datasheet, which has only been generally available for a year or two now in the community, but looking at the datasheet for the 6847 T1, the pinout is a bit different between this T1 and the original 6847. Some of the pins look to be there to support what they call pseudocolor, which is the NTSC artifact color mode. I guess the color mode kind of left out earlier that's not really supposed to be supported by the chip itself, the 6847 T1. It only really became available as a quirk of how the how the 6847 interfaces to the aforementioned MC1372 chip for the color encoding. And quirk in some early CoCo motherboards would generate a condition where, even though color information was supposed to be turned off so that you get a pure black and white signal going to the TV, in this mode, in the right or basically in normal conditions, but in this mode, it would turn on that color information, and so that's where you would get the the aforementioned black, white, red, blue 4-color mode instead of the higher resolution black and white mode. Again, this proved popular in the CoCo, and so popular that when the original CoCo 2 came out, lacking that support because of a redesign of the motherboard, Tandy actually had to go to some trouble to put that quirk back into the CoCo 2. And so apparently somebody pushed for that in the T1, the 6847 T1, and so there's a pin on this T1 that actually looks to me like it's designed to facilitate implementation of that color mode. So I did ask John Dumas about this, and he seemed unaware of that. So I don't know if this project came about after his tenure with the 6847 or not. But anyway, it looks like it's there. To me, it's labeled a pin labeled Burst PC for pseudo-color burst. Also, looking at the datasheet, there's some hints that there might be some support for having the high-speed poke enabled at all times. So on the normal CoCo, you can only have the high-speed, the 1.79 megahertz speed available when video is not being displayed because of just the way the clocking is done with the 6847, 6883, and 6809. But anyway, I didn't quite make out what they were trying to say in the data sheet, but it sounded to me like they were intimating that with the right circuitry, it's possible to have the high-speed poke on at all times with the 6847 T1. I don't recall seeing that listed as an advantage for having one of these chips in any of the CoCo literature. I may have missed it. It might be that it's well known that it's possible and I've just missed that information, but it might be worth some further investigation if that is not known. It might be possible to have that on, and on those so equipped CoCo 2s, that might be interesting for some applications. Or, I could be imagining things, and it might not be there at all. Well, I think that probably covers most of what we wanted to say about the 6847. I hope you've enjoyed my rambling, and I've tried to keep it down a bit. Don't know how successful I've been, but anyway, I hope this has been enjoyable for the listener.
Get ready, player. 1.
Welcome to the Games Corner. On this episode, I will be doing my first ever CoCo video game review. The game I have chosen is called Rupert Rhythm, the Music Box Caper. I have chosen this game to be the first because it has a sentimental value to me. Going back to late 1988, I had joined a color computer users group in my hometown. We used to meet up every month and discuss anything CoCo related. It was very educational, and I learned a great deal from the other members. I had also learned that this users group had a massive CoCo software library that was available to any members. So this game was the first program I ever borrowed from the library. It was also the very first, I guess you can say, commercial CoCo 3 game I saw in action. You have to realize, up until this point, I was still very new in the CoCo world. I had just got my first CoCo 3 only a few months before, and all I was doing on it was learning some disk commands, basic language, and typing in programs from magazines and manuals. Compared to the other CoCo veterans out there, I was a latecomer. I skipped right over the CoCo 1 and 2 and was lucky enough to get a CoCo 3. After the meeting was over, I just couldn't wait to get home and try out this game disc. I walked in the door and went straight downstairs to boot up this game. I put the disc in, typed in the loading command, listened to the sounds of the disk drive churning and clacking away, and all of a sudden, wow, what a surprise. This was a real treat for sure. I was greeted with amazing metallic shading, high-res graphics, and real digitized sound. I had no idea what to expect, but certainly my hopes were not this high. Let me roll you a clip of the digitized sound in this game so you can hear it for yourself. It's absolutely incredible. Now, keep in mind this game runs on a stock 128K CoCo 3 without any extra hardware or upgrades. Rupert Rhythm is a platform-style game with a puzzle element to it. In this game, you have a main screen, and on the screen you have 16 doors that lead into rooms. In each room, you must walk on every platform to change its color, kind of like the game Q*bert. Here's where it gets tricky. Each platform is scattered around and is different in each room. In order to get onto these platforms, you must wait for the moving elevators. Then if that's not hard enough, there's also droids you must dodge. You cannot kill these droids, but you do have firecrackers to scare them away and pet pills that allow you to temporarily walk over enemies without dying. Once you walk over all the platforms and change their color in each room, you will receive a piece of music. After completing this in all 16 rooms, you will have enough pieces of music to make a complete song, and you will get a mini concert at the end. My friends at that time would come over, and they were blown away with how amazing this game is and what the CoCo 3 could do. All of them had either VIC-20s or IBM XTs with CGA 4-color graphics with PC speaker for sound. And here this $199 stock CoCo 3 could do all this. They couldn't get over it, and neither could I. From that moment on, I was a true CoCo fan. Rupert Rhythm is programmed by Nick Morentis, one of the original legendary CoCo game coders. We are very lucky in the CoCo community to have Nick. He is still very active in the community. We mentioned earlier in our news segment, he released an update to his Neutroid game called Neutroid version 2.015, updated for the CoCo 3 with enhanced graphics. He is also currently working on a brand new side-scrolling shooter game called Popstar Pilot. Thank you, Nick, for all you do. All of us really appreciate your hard work and dedication to the CoCo. I will also note that Nick has made Rupert Rhythm free to download for anyone who wishes to give it a whirl. It's available on his website and also on the Color Computer Archives. I will add the links into the show notes. Well, that concludes another Games Corner segment. I hope I just convinced you to get your CoCo 3 if you haven't already got one.
After these messages,
we'll be right back.
Well, it's that time again. We have reached the end of episode 2. We hope you enjoyed the show. Please keep your feedback coming in. We'd like to hear from you. I would like to thank my host, John Linville, for providing yet another fantastic tech segment for the CoCo community. We also would like to thank all of you for listening. Again, if we didn't have you, there'd be no point in doing this podcast. Stay tuned for next month's show, and until then, happy CoCoing.